This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
Welcome back into Viterbi Voices. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the USC Viterbi School of Engineering. And thanks for joining us again. This is another bonus episode, another Academic Department Faculty Roundtable. This time, the faculty from the Mork Family Department of Chemical Engineering and Material Science joined me for a long-range conversation about the discipline of chemical engineering, about the department, about the classes, about the research, and it's a good one. For this intro, it's just me again. As you know, if you've been listening, yes, Audrey's still doing great. She's in Denver. I'm here in my home, and for those of you that have been listening through all of our last episodes where I was crying and whining about the rain, today is Monday. It is April 13th, and the sun came out, and it's a gorgeous day. Still didn't get outside because I was working all day, but I'm excited to know at least I had some sunshine coming through my window. And I hope that this episode is finding you all doing well and staying healthy and safe wherever you are. And hopefully this is going to come out to be ending up sooner than later. But this episode, Chemical Engineering Material Science, the Mork Family Department. We've got three faculty. We've got Dr. Robert Young, we've got Dr. Steve Nutt, and we've got Dr. Iraj Ershaghi. Fantastic guys, lots of fun, good conversation. Audio goes a little bit in and out here as you go through it, but I still think it's a helpful episode. So if you've been admitted to chemical engineering and you want to know about all these different disciplines like nanotechnology and sustainable energy and petroleum and biochemical engineering and environmental, chemical engineering does a lot. And I think that's what they talk about here, is that it's very broad. And so when you have that background in chemistry and you're thinking about how you can apply that in producing materials or coming up with new types of solutions for things, then this is what we're going to deal with in this conversation. And I hope you get a good take on this whole thing of chemical engineering material science. If you need anything from us, we're still here, and that's viterbiadmission.usc.edu. We got a web chat function there. We're happy to be working with you on when we're actually in our working office hours, or give us a call at 213-600-9919. If you're an admitted student and you haven't made that commitment deposit yet, you got to make sure and do that by May 1st, and that's going to be at admission.usc.edu/status. So enjoy this episode with the Mork Family Department of Chemical Engineering and Material Science. Good morning and welcome to the USC Viterbi School of Engineering Department Faculty Roundtable with the Mork Family Department of Chemical Engineering and Material Science. My name is Paul Ledesma. I'm the Director of Undergraduate Admission at the USC Viterbi School of Engineering. It's fantastic to see all of our guests here join us as newly admitted students to the Department of Chemical Engineering and Material Science. I am going to go ahead and mute everybody in the chat so we can not have any interruptions here. But our faculty that are joining us, they will unmute themselves. So they're going to be able to get started and chat with us for a little bit. Today's session is going to be all about connecting with the faculty, connecting with the department, and learning more about the discipline. And so we have some great faculty members that are here joining us to represent the department. I'm going to let them introduce themselves. First and foremost, we'll start with Dr. Robert Young.
So, I'm Robert Young. I am an associate professor of practice, which means I teach in chemical engineering. Before I came to USC, I've been at USC teaching for about 6 or 7 years. Before I did that, I worked for ExxonMobil for over 25 years. So I have a lot of industrial experience. Primarily, I teach junior, senior level courses. I've taught the labs. I've taught process control. I teach the final design sequence. And I like to be involved in things like the student AICHE organization and things like that.
All right. Thank you, Dr. Young. Next up, Dr. Iraj Ershaghi.
Okay, hello everybody. My name is Iraj Ershaghi. I'm a professor at USC School of Engineering. Our department is Mork Family Department of Chemical and Material Science. I've been at USC for 48 years, and specifically, I'm in charge of the petroleum engineering program, which is an undergraduate option in chemical engineering. And my area of research is basically in three areas. One is reservoir characterization. Our expertise are in characterization of subsurface reservoirs for various purposes, energy extraction, as well as energy storage, CO2 sequestration. And the second area is smart oilfield technologies. And this has to do with using the digital technologies to bring more automation to oilfield operations. And the third area is well testing, which is a specific area of research, has to do with how we can run certain tests and interpret the characteristics of large bodies of what's on the ground. So I welcome your questions, and I'm here waiting to hear about any discussion you will have.
Great. Thank you, Dr. Ershaghi. And last but not least, Dr. Stephen Nutt.
Thank you, Paul. Welcome, everyone. I have been a professor at USC since '94, so that's a little more than 25 years. I am the director of the material science program, which is a graduate-only program. But we do teach undergraduate courses in material science, some of which are taken by chemical engineers, mechanical engineers. My research area is composite materials. These are the materials that are used in aerospace primarily, but also in sporting goods. And my focus within that scope is manufacturing of composite materials. Oh, and this is my USC t-shirt.
Looks good.
Yeah.
Looks good. All right. So for all of our guests, here's how this is going to go. I'm going to lead the faculty through a discussion to talk about the discipline, the curriculum, and just get some questions from them, get the discussion going. As we get toward the end of the program, toward the latter half, I'll open it up for questions. For the time being, just hold the questions to yourself. Be thinking about them if you like. But toward the end, I'll open up the chat, and then we'll take questions from all of you. So be thinking about them right now. Please don't put anything in the chat until we get to that point, and we'll get to as many questions as we possibly can. The first question that I want to get out to our faculty, and it's rather open-ended. It is going to be incredibly vague. So whoever wants to jump in, however you want to get in there. But let's start with, what the heck is chemical engineering? Let's keep in mind, I'm a high school student that has just taken chemistry.
Okay, so chemical engineering, to me, chemical engineering is an engineering that focuses on manufacturing of materials. So many years ago, when I was coming out as a chemical engineer, it often meant that you were working in a chemical plant or a refinery. Some people, depending on their degree programs, would go do petroleum. But now we have students that work in all sorts of different industries. I have students that have gone to microelectronics. My son, who has a degree from USC in chemical engineering and a master's in material science, currently works for Applied Materials that makes devices that make microelectronics, but we also have many students that work in petroleum industries. We have a bunch of students that have gone to, for example, Schlumberger, doing well monitoring, undergraduate students. We also, bio or pharma. I have several students who are currently working in pharma down in San Diego, as well as other consulting type roles and other industries.
Any other thoughts, Dr. Nutt, Dr. Ershaghi?
Yeah, I would answer. I've asked a slightly different question, and that is, like, what is engineering? One of my favorite interview questions when I interview high school students is that to ask them to explain to one of their friends how they would explain to one of their friends what engineering was. And the reason I like that question is I find that a lot of high school students don't really know. It's not surprising. There aren't many TV shows or movies that have engineers as the main character. But there is an activity that's common to all the branches of engineering: chemical, mechanical, aerospace, biomedical. And it's engineers design and build things. That's the one that I think the central activity that connects all of the engineering disciplines. And I also think it's what engineers find particularly gratifying, in the sense that they can actually solve a problem through their design, and then execute the design, build it, and show that it works. And I find that gratifying, and I think a lot of engineering students, when they graduate, also find it gratifying. But I think a lot of high school students aren't aware of that. So design and build.
Absolutely.
Let me also mention a few words here. At the USC Viterbi School of Engineering, our dean always talks about engineering plus. And the whole idea is that engineering is really getting into many, many areas. So we have very close collaboration with the School of Medicine. As you might imagine, many of the instruments that are designed and manufactured are actually the brainchild of the engineering graduates. And then we are working with the School of Cinema. We are working with the School of Journalism. So the whole idea is that we think that engineering, having that mentality, is really the way to solve many of the societal problems. Whether it has to do with the clean water, it has to do with sources of energy, it has to do with manufacturing, it has to do with the materials. And so the people who get into engineering, as Dr. Nutt indicated, not only have the passion for understanding the science behind it, they also understand, or they practice the economics. What is doable, what's feasible, what the society can accept. And that's what it makes it a very honorable profession from that point of view. Go ahead.
So help our audience understand the undergraduate curriculum toward chemical engineering based on those kind of broader set of goals of what engineers do and what chemical engineers do. And if you wouldn't mind, I know this is going to be a more detailed question, but there are a lot of emphases and specializations inside of chemical engineering, and even discussing what chemical engineering is doesn't get down to those end case scenarios, right? So how do we help a student entering your program understand what's awaiting for them in the undergraduate coursework? Yeah, go ahead, Steve.
You want me to start? I let Dr. Young start, and I'm going to have some comments.
Okay, Dr. Young's going to start. Go for it.
Okay, so I mean, our curriculum is gonna. There's a core set of chemical engineering and engineering electives that people take. But as chemical engineers, we also there's a significant number of math classes, a lot of chemistry classes. I find a lot of my friends who are chemical engineers got into chemical engineering because they liked chemistry. And then if a lot of them, like me, really didn't do very much chemistry throughout their career, right? I mean, and like Dr. Nutt said, there's a lot of design, there's a lot of other aspects to engineering. But we do students take a lot of chemistry, and then we progress through a set of different courses where students learn fundamental engineering, fluid mechanics, heat transfer, mass transfer. Two of the biggest things in chemical engineering that separate engineering from other disciplines, chemical engineering from other disciplines, is reaction engineering. So how do we take a raw material and turn it into something that's useful and improves people's lives? And how do we separate the products once we've made them, right? So there's a lot of coursework that goes there. And then as students get towards the end of they do design classes. There's also opportunities to focus in different areas. There's a material science option, there's a nanotechnology option, there's a biomaterials option, a biomedical option, petroleum option. We just started a new option, and we're talking about starting one in data sciences. And then you can do chemical engineering and kind of make your own option. There, you can with proper advisement, you can go through and select electives that make your own personal option. Steve, you probably have other things to add. Iraj?
Well, yeah, one of the things I wanted to mention is well, if engineering is about design and build, you might wonder, well, when do I get to design and build something? When is my first experience with that? And that the answer to that is starting next year. It'll be in your freshman year. We've just completed what we call a makerspace, where undergraduate students, will have access to a space equipped with tools, 3D printers, staff members, where literally you can go and make anything you want, anything you can
Let's add
imagine.
within reason there. Let's add within reason to that comment. Yeah.
Well, okay. Yeah, I guess that's true. But it addresses a problem that was basically in the structure of most engineering school curricula, and that is the first 2 years were so heavily stocked with basic science and math courses that engineering students really didn't get a taste of designing until their third and fourth year. Well, now that's going to happen in your freshman year. So we're pretty excited about that. That new space is somewhere behind me and Paul.
Yeah, it's over here, this way.
Yeah, there you go.
Iraj?
So I'd like to add a few words over here. Of course, realize that USC is a private school, and you can see the difference the minute you get on campus. The difference is that you get the feeling of working with the faculty. You select a mentor to work with you, and I think it's through that mentorship experience and through the summer internship experiences you should have, you develop a personality about what area you want to pursue. And so it's partly education. You get the general education the first 2 years, then you get a specific the third year and fourth year. But you really have to combine that with the private sessions we had with your faculty mentor, and also working at different entities, companies. In the summertime, many students in the sophomore year actually get some sort of a summer internship, and those are very helpful. So you really have to combine all of that and make a personality for yourself, what your interest areas are. And now we do detect a few people who really have the potential of going for advanced degree, master's or PhD, and we bring it to their attention through the research productivity they have. That's for a selected few, but the majority of the people who get out, they develop that engineering personality with a combination of coursework and getting the attention of the private school professors. And this is something that really would distinguish USC from other schools that don't provide that opportunity.
Great. Thank you very much. Could anyone want to take this, or each of you talk a little bit more about research in the department and maybe your specific areas of research or the goals in general in research related to chemical engineering and material science? Iraj, you want to get us started?
So the research would be, again, we do have some undergraduates who work with different faculty, but really the research is started at the graduate level, master's and PhD. And depending on the expertise of the faculty, and depends on the emphasized by the funding agencies or the corporate funding, our research areas, again, have changed over the years. But if you look at just the petroleum engineering, which is one of the areas of emphasis, right now we are focusing on clean energy. We are working on CO2 sequestration. We are working on reservoir characterization. We're working on reservoir modeling. Many of these research areas actually has a heavy dosage of using smart devices, smart algorithms. So it's kind of a combination of mixing the research area with the expertise that faculty have in the area of computational science. So very much oriented in that area, but we also have experimental labs. So we have experimental labs. We're doing some work on unconventional resources. We run experiments that has to do with how you can enhance the recovery from these tight reservoirs. And so one of the things I should mention is that USC is blessed with having very significant industrial funding. I myself have been running a center since 2003 as heavily funded by Chevron. And we work with sometimes 20, 23 faculty in different departments that really have interest to work with us on areas related to the smart devices, smart tools, and smart algorithms. For instance, we develop techniques that will make it possible for you to run sensors without a battery and by extracting energy from the environment. So we do a lot of neat things. But this idea of collaborative research, which is very much emphasized at USC, is really one of the opportunities you have to be able to work with different faculty and make progress in that area. And again, since at least in our program, we get a lot of industrial funding, you can see that the work we do are very much relevant to the day-to-day use and application of what's needed by the nation, what's needed by the society. So we, again, depending on the expertise of the faculty, we have different areas, but we do emphasize quite a bit of collaborative work with faculty from other departments.
Thank you. Steve, yeah, go ahead.
I have several undergraduate students working in my lab, some of whom are chemical engineers, some of whom are mechanical engineers. That provides opportunity for what I call cross-fertilization. The tools in the toolbox of the chemical engineer are different from those of the mechanical engineer. So there's a lot of learning, peer learning that goes on in the unstructured environment of a research lab that's quite different from the classroom. Some of my chemical engineers, basically, once a student joins my group, my attrition rate has been almost zero over the years, which I think speaks well for the experience that the students get. Some of my chemical engineers actually go to work in aerospace industry. Tricia Pallett is going to work for Northrop. She's a chemical engineer who's been with me for 4 years. Madeline Sheedy is also going to work in the aerospace industry. She's also a chemical engineer. So there, as Paul and Robert mentioned, the chemical engineering degree is extremely diverse. Versatile is the word I wanted. In that the tools that you're equipped with through the degree enable you to go in a wide variety of directions, from aerospace to Microsoft to petroleum and the chemical industry. So it's a good choice.
So one of the things that I don't do research. I'm a teaching faculty, but of the one thing I would say is, of the approximately 35 seniors I've got right now in my design class, well over half of them are doing undergraduate research in somebody's lab. Some of them are in, Tricia's in my class and works for Professor Nutt. Some of them working up for other material science faculty. Some of them work for chemical engineering faculty. I have several that are doing work in chemistry with people on battery technology. Several that do work in bioengineering. So those opportunities, while a lot of people think of them as being more graduate level type opportunities, there are lots of opportunities if you're interested in doing graduate research or getting an experience in or in doing research, so that you can figure out if you want to go on or not, right? I mean, that, to me, that's one of the nice things is you can get that experience as an undergrad, decide if you want to pursue a graduate degree.
Great, thank you. This was something that was touched on a little bit earlier, and I want to dive in a little bit more detail on this, which is theory versus hands-on. And definitely there's a split between the two, but maybe Dr. Young, you can start us off on this one. Can we describe what it means to do hands-on work inside of the curriculum, projects, labs, etc., and then what theory means? Because a lot of schools will lean heavy on one or the other, and we're pretty good evenly split between that.
We have at this stage for our undergraduate chemistry core curriculum, we have 3 different lab classes that students take. We just recently restructured it. So now instead of waiting until the junior year, we're having students start with labs their sophomore year. That gets some hands-on experience sooner. We've also aligned it probably better with the curriculum. Then also, as we keep going, there are classes that are very theoretical. But you need that theory. But there are also classes that are very practically oriented, and so you get a very good. Our curriculum has a very good mixture of those. As Professor Nutt said earlier, the material science classes. I know that the undergraduate petroleum classes all have laboratory experiences as well. And one of the things, building off of something that Steve said earlier, even our upper division students who are members of AICHE, so the American Institute of Chemical Engineers, they've started the last 2-3 years. They've put together an undergraduate design challenge that the freshmen and sophomores participate in, and I'm really excited about this makerspace because I think that design challenge is going to get nothing but better as the students have access to the makerspace.
Very cool. Anything else you both would like to add on to that, and the ideas of what is hands-on and what is theory? I thought that was a great answer, though.
I should mention that this is part of engineering. This is really what distinguishes engineering from other fields, that you need to have domain expertise. You need to have the background where things come from, how things are related. But you do have to do a lot of investigation hands-on now. Of course, the hands-on definition has changed over the years. We used to do a lot of experimental work, wet lab type research. But as you get to the graduate type of research, you can see many of those hands-on are actually computer simulation. Many of those things are actually numerical things that you do. So you will see that as an engineering student, your skills will be significantly better than many other disciplines because of the fact that not only you have experience working in a laboratory, but you also have significant experience actually, working with numerical simulation and modeling. And I think the combination of all of these things really helps you to make a much, much better prepared engineer for the day-to-day use application.
Thank you. Again, my next question is probably teed up specifically for Iraj, but anyone can jump in here. And I'm going to kind of give him a softball here. Energy and the future. I think that sometimes students come into this discipline or come interested in the ideas of energy thinking oil is evil. And I know that you do a lot of research and you have a lot of background in the ideas of petroleum engineering and specifically your discussions into renewable energy and sustainable energy. So can we give a quick talk about what it means to be working towards the ideas of energy in this country, and specifically how chemical engineering or petroleum engineering plays into that?
Well, that's going to take a couple of hours. just
Yeah, I know. I'm sorry. Let's do the forward to the book that you've written.
I think very briefly, energy is probably more important than food because you do need energy to produce food. So energy is a very important need of the society. Whether you talk about transportation, or you talk about heating, or you talk about power. Whether you want to energize a generator that will actually, create electricity for your car. No matter where it comes from, we do need energy. Now, traditionally, the industry has changed from wood burning to coal to oil to natural gas. Now we're gradually going to hydrogen and we're going to the solar. And this transition takes some time. It takes time, and it has to make these things more economical, and has to make sure that we have plentiful of these resources. Currently, about 60 to 80%, actually, depending how you look at it, what part of the country, of this thing come from fossil fuels. Gradually, we are, minimizing the use of coal. We are still working on natural gas and oil, but gradually you can see as we look into the future, you're going to see the demand for natural gas will increase because it has more hydrogen per carbon than coal and oil have. combined, and then you're getting to the point that eventually we will have a source that will generate hydrogen, that the world is going to go toward hydrogen. How long would that take? Who knows? It all depends on economics. And when the oil prices or gas prices are depressed, when they're low, it actually makes it difficult to focus and to promote other forms of energy. But when these resources get to a level, then that will make it possible to focus more and more and make it economical on using other sources of energy. You can see that you can call yourself an energy engineer that will have expertise in different areas to be able to provide those resources. So who knows how the future is going to be, but my personal prediction is that at least for the next 50 to 60, 70, maybe 80 years, we're going to be depending on natural gas. And after that, who knows? If we have made enough progress on advancing and making it economical to use in other sources, we might go to hydrogen, we might go to solar, but it just takes time. But doing research in these areas, making it economical, making it possible, is really one of the things that our chemical engineering students do. People who are, especially in materials, that are actually working and specifically on these areas, that making materials that will actually make the solar energy much more affordable in terms of efficiency and in terms of price. And you can see also the traditional form of chemical engineering and petroleum engineering is changing, because we realize that the only way we can continue on fossil fuel for several years to come is to be able to get rid of the carbon. And as you can see, the industry and the government is heavily working on CO2 sequestration. How can you store the carbon that you produce so you can benefit from these sources, but not to worry about adding more carbon dioxide to the atmosphere? So it's very exciting. It's something that there's always demand for it. There is always will be demand for it also in the future, but there are complications, and we are working on those complications, making sure that we can make them affordable and we make it beneficial. And this is really the challenge of what we are working on.
That was great. Thank you for summarizing a very complex question. I appreciate it. I want to tell our audience to start getting their questions ready. We're going to give you an opportunity to ask questions here momentarily. But before we get to that, for our faculty, would you all mind, we're talking to admitted high school students. They're looking at the world in front of them. They've been admitted to fantastic universities and they're trying to make a choice. Would you mind taking us through your, some of you did this briefly in the beginning, but if we can get a little bit more specific, your educational background. We don't need to go back to elementary school, but maybe where you went to undergrad and forward, and how you found yourself at USC. Steve, why don't we start with you?
I went to undergraduate school at the University of Virginia. I was a physics major, and I thought that was excellent training for my future career. But I realized there weren't many employment opportunities for physics majors, and so I made a transition to material science and did my PhD at the same institution. And then I kind of moved around a little bit. I worked at a national lab at NIST for 2 years as a postdoc, and then 2 more years as a research professor at Arizona State. And then I joined the faculty at Brown University for 8 years before coming to USC. So I've been in the academic vein for most of my life. And it's been a good place. USC's been a really good place for me. Yeah, I've enjoyed it there. I'm happy to be part of it.
Great, thank you. Dr. Young.
Yeah, so I did my undergraduate degree at the University of Texas. When I finished up, we were going through an oil crisis. I had thought about working I had an offer to work for a engineering and construction company that built chemical plants. But I decided that I wanted to go to graduate school and do process control. So I went to University of California at Santa Barbara and got a master's and PhD there. From there, I decided that what I wanted to do was go and work. So I worked for a subsidiary of Honeywell doing automation, optimization, process control. I did a lot of work for polymers plants, but I also did some work for Chevron and in Bakersfield in the oil fields. I did some work for some other plants in Toronto, Illinois. And after doing the consulting thing for 3 years, I traveled 60% of the time and worked too many billable hours. And an opportunity came up to go to work for ExxonMobil, or actually at the time it was Exxon. So I worked for Exxon in Baytown, Texas for a long time, 10 years, doing basically process control and engineering for polymers plants. And then I had an opportunity to move. Actually, my wife had an opportunity to move. And so we moved to Southern California, and where I worked for the Torrance refinery for 15 years, actually a little over. And there I started off as an automation control person, but I also managed the quality assurance lab. And I finished my tenure there. I was in charge of safety for the entire refinery, which so now I've always had a passion for safety. If you pay attention to the news, you'll find that periodically we have chemical plants, refineries, other facilities that need to work on their safety. They impact the public. So yeah, there are lots of opportunities. I've been at USC for 5 years, and I taught here part-time for 2 years before that.
That's great. So in your background, definitely lots of steel-toed boots. That's what I was hearing.
Yes, steel-toed boots and hard hats.
And hard hats, absolutely. Dr. Ershaghi.
Well, my life story is summarized in a video which is on a website of the Mork family department. But in brief,
this is true. You're a celebrity in that animated video, right? It's really cool. Everybody should look for it.
From childhood, I always had a lot of interest, and I was fascinated by looking at rocks and minerals. And this was really built in me. In fact, if you come and visit our house, you can see I have one of the best rock collections. So it was fascinating to look at rocks and making sense out of them and see how you can extract anything out of them. So originally, I was a mining engineering student at the University of Tehran, but then later on I switched to petroleum. And then that has been my passion since, God knows, 1961. And I worked for a number of companies before I started teaching at USC, and these companies included an Italian company, IG Mineraria, California State Lands Commission, and Signal Oil and Gas. But when I worked at USC, I always kept that contact with the industry, and that's the reason why I've been very successful in getting industrial support. So through my connection with the industry, I've been able to not only bring funding for the work that I do, but also be able to have that connection that would place the students on internship and summer jobs on full-time. And I always think that's a very important dimension of the responsibility we have as a faculty. So I've been fascinated by how in our field, which we call the subsurface engineering, you can actually use very limited data because you don't drill million wells, you only drill maybe a handful, and you're able to get the data from a limited number of points and actually interpolate in between by using all kinds of stochastic techniques. That has been very fascinating to me. And so there's a lot of knowledge and experience in that area that has been developed over the years. And I cherish all that. And again, my specific area of expertise has been well testing, where we actually try to form various techniques of pattern recognition and artificial intelligence to be able to recognize the signals. And by signal processing, we're actually able to estimate properties of surface reservoirs. So over the years, I have changed depending on where my funding came from. At some times in my career, actually, I work on geothermal reservoirs. There was a lot of development in California. And that's a clean source of energy because you produce high temperature steam you can actually send to the power plants and generate power. And so that has been a fascination also. I still do some work in that area. but primarily my work has been in oil and gas since I joined USC.
Great, thank you very much. Let's open it up to the questions. So anyone in our audience out there, whatever your questions are, go ahead and put them into the chat. We'll try to get to as many as possible. I'm going to let some time go by where I can kind of process these. I'll try to also consolidate. Sometimes some of you have similar questions, so I'll consolidate as we go. Let's see. No questions yet, so I'll come up with a new one as we're waiting for these questions. Oh, there we go. How would an undergraduate get involved in research? Thank you, Daniel. So how would an undergraduate get involved? Let's say they're going to join us. They're going to be there this fall. What are their next steps?
Okay, I should mention comments here. So we've had a number of programs in that area, but there's a new program being worked on, and I highly encourage the students entering USC in engineering actually to apply for that. This is a brand new program that hasn't even been announced. And under this new program, actually, we have a number of corporations who will sponsor what's called the Viterbi Scholars. And as a result of that, now your students are able to work with different faculty and study sophomore and junior years and develop techniques and solution methodologies that would be publishable. And we think that kind of a one-to-one relationship that they have with different faculty is going to be very helpful. Now, on top of that, of course, School of Engineering has been very successful in placing undergraduates in different laboratories and different research projects through the National Major Scholars and other programs that we have. And I think Matt can tell you more about it. Maybe Paul, you can say more about the School of Engineering undergraduate. You're familiar with all that activity.
Yeah, I'll bring that up toward the end. But let's see that. One of the questions is, how would an undergraduate student join one of your labs, or what would you look for in an undergraduate if they reach out to you? I mean, one of my main advice is, talk to faculty as you start taking classes from them. Is that a good bit of advice?
Well, the first thing is, of course, you can do this up to a point that you're a freshman, sophomore, you probably get a lot of advisement from the School of Engineering in general. But gradually, as you get more and more involved in the department, you begin to know the faculty, very friendly faculty, actually. You just have to make an appointment and see them and see if they have something for you, and you can get started.
Yeah.
That's very easy.
Steve, you want to jump in here? Because you're typing. I want to make sure you get that on the audio and video recording, because the recording won't have the text.
Yeah, there were a little too many questions to respond to at once. But with regard to getting involved in research, I would say contact the professors, plural, that are doing research on the topics that you're interested in, and contact them directly. Ask to make an appointment to do a face-to-face. Also, talk to other students. That's a good additional perspective to factor in. What's it like to work in this professor's lab? And particularly upper class students that you in your same program. Then, and what do I look for? Yeah, well, that's a good question. And I it's hard to put into words, but I tried maturity, professionalism, commitment, like someone who's really going to show up consistently and put in the time and effort. It's one of those situations where you get out of it what you put into it. And research is, it's difficult to do part-time. What I do with my undergraduate students, I typically assign them as a sort of apprentice to a graduate student, working on like a mini project, something tractable that is sort of matched to the background and capabilities of the undergraduate student. Now, being high school students, you don't have many skills. So we have to start, modest with small things that enable you to feel productive and feel like you're contributing, but also get a feel for what it's like in the research lab. I think Robert mentioned earlier, that's one of the chief benefits of the research experience. It's not for everybody, frankly. But the only way to determine that is to try it out. Now, there were some other, someone asked about publications. Yes, there's opportunity to publish, but typically that takes a couple of years of effort. Given that undergraduates are working part-time on research, it takes a while to get to that point. Tricia, the student that we mentioned earlier, is a senior, who's been with me for 4 years. She has a manuscript where she is actually the lead author. That is in the final stages of review. We will be submitting that probably in a couple of weeks. So yes, it's possible. Not all my undergraduates end up, co-authoring manuscripts, but it is possible.
Absolutely. And I think that ties into another question, which is they're saying, can I do research across multiple labs, across multiple schools like Viterbi and Dornsife? And I think that, you've got only so many hours in a day. And so when you talked about commitment, that's an issue. Yeah, Steve.
Well, my initial thought on that question was it's not easy. However, there is one project that I have that involves a collaboration with a chemistry professor to develop technology for chemical recycling of composite materials. And there is, that project does actually span Dornsife and Viterbi. And there are undergraduates from both schools on the project, as well as PhD students. So
yeah, thank you for clarifying that. Yes, there are a number of projects that are multidisciplinary, and so they have lots of different people involved across it. But having multiple, like for example, having multiple jobs is probably going to be hard to do. Being, you got to take classes full time. I think that's the hard part there. In addition to when you're an undergrad, I think a lot of you are discounting how you're going to be spending your time with doing lots of different things, lots of different activities. And I think what's a thread here. Oh, Steve, please go ahead.
No, I was while you were talking, it reminded me of something. You do have limited hours, and for freshmen in particular, we cap the number of hours that you're allowed to work in the lab at 10 hours per week. My advice that I give my students, particularly freshman students, is look, you really need to focus on your courses first. You need to, what I say, I call it, you need to protect your GPA. It's difficult to recover from a bad semester in terms of your GPA. So until you are calibrated to what time and effort is required of your courses to get the results that you're going to be happy with, I would say focus foremost on your courses. Do research as time allows, but and then once after your first year, you've sort of are calibrated to the effort that you need to put into your courses, then your time in the lab can expand. I think we limit it to 20 hours per week after the freshman year. So anyway.
Yeah, that's the max for any undergrad working. Oh, Iraj, yes.
Yeah, I see some of the questions over here. Maybe I can answer two of them. One has to do with, let's see, is it difficult to obtain internship? And one of the things we encourage highly is student involvement in professional and student society. So we have AICHE, AICHE, and we have PD and other programs. And through those involvement, you actually begin to know the industrial people who actually are in the process of coming to the campus and interviewing. So the more you get involved besides your academic work in these student professional societies, I think the better chances you have to be connected to the industry. The next question was, what percentage of the students pursue advanced degrees? I should mention that many of the students who transfer in advanced placement courses to USC, where in the senior year they have the room, they actually go for PDP. This is the Progressive Degree Program, which makes it possible for them to spend one more year and they get a master's degree. That's interesting. Some students actually stay and do that one extra year, do a master's. Some students are admitted to the PDP, they get a job, and actually the companies support that fifth year, so they're doing their master's on a part-time basis with distance education. I personally highly recommend that, the PDP and advanced degree, because that actually will give you a little bit more content in terms of whatever you're doing. And of course, sometimes at the master's level, people stop because they have a job, they're very happy with what they're doing. And occasionally, some of these graduates get back to the campus because of the work They've done with the faculty, they do PhD, but majority of the PhDs, necessarily are not our own students. They may come from other schools, so that, they know of a particular professor they want to work with the computer. But let me emphasize again, it is extremely important that if you have a chance to get to the PDP, do that extra 1 year and get a master's degree, whether it's supported by the company who hired you, or whether you're paying for it, or whether you can work out something. That's extremely become more important, where in many areas, really the master's degree is becoming the first degree in terms of having the preference, in terms of employment, in terms of expertise, in terms of the handling some of the complexity related to the work that you're doing.
Thank you for bringing up those questions. I want to bring up just a couple kind of resources that students should know of, and then we'll get back into this. The idea of interning, students that want internships, definitely get them. We have a lot of resources that are working with you to bring hundreds and hundreds of employers onto campus every single semester for internships, co-ops, or full-time positions after graduation. Our own Career Connections office, which is devoted to engineering undergraduate students, is going to be working with you from day one and helping you with that process. I think what's important is that's a process that you think about as early as your first semester at USC. It's kind of a common thing that I'll say is that you don't look for jobs senior year, you sign for jobs senior year, because that's the accumulation of 4 years of gaining internships and networking opportunities and working with those employers over that time. In addition to that, we have some surveys of our graduating students that the grand majority of our undergraduate students go straight on into industry. It's about somewhere between 70 and 75% of each graduating class are going straight into industry with their bachelor's degree. Now, that said, when we do alumni surveys down the road, the majority of them have some sort of advanced degree. It's actually about 75% have some sort of advanced degree down the road. That doesn't necessarily mean it happens right away, because as Dr. Ershaghi mentioned, this idea of sponsorship from companies definitely gets into play. Sponsorship to go on to advanced degrees in engineering, advanced degrees in other disciplines. I know of a number of students that go get their MBA. There's a lot of opportunities, because it is that it's designing and building is problem solving, definitely. So there's lots of stuff there. I wanted to have someone talk a little bit more about the idea. There's a question here about the biological type emphasis, which is our biochemical engineering emphasis in chemical engineering. I'll give a quick recap of the curriculum, but basically it takes the chemical engineering curriculum, it adds in more biology courses, molecular biology, biochemistry, et cetera, with some biomedical engineering coursework and biochemistry coursework in there to focus on that. But can we talk a little bit more about the ideas of biomaterials? Anyone want to jump in on that?
Not me.
I know it's not your area, Steve.
So we have several faculty that do focus on that. I mean, Noah Malmstat does biomaterials, soft matter type stuff. We have some other, we have several, Professor Wang, Professor Roberts, Professor Graham all do a variety of, not necessarily biomaterials, but either bioinformatics or biomedical type applications that are all in the department. So we're bringing in a new person this fall that I think has some interests in materials and biotype processes. So we've got a nice core of faculty that do that kind of material. We also have good linkages with, Professor Ershaghi had said this earlier, with the Keck School of Medicine and with our own bioengineering program on campus, where we do interactive type work, or where those faculty members have joint appointments in MFD. So I think there's lots of those kinds of appointment or interactions going on.
That's great. Thank you. Now, with this next question, I think there's a great opportunity to also make sure we say hello to someone that's been with us from this whole time, and that's Karen Wu. Karen Wu is the undergraduate advisor for the Chemical Engineering Department, and we have a question here about what's it like to choose classes? What's the process like for choosing classes? And as you go through this process, I'll start it off with orientation is going to happen this summer, and so orientation, there's a lot of discussion right now with the ideas of moving orientation to an online process. We're working to make sure that we make this as frictionless as possible possible. So there's a lot of things that are still TBD for this summer, but everything will be online. It'll be virtual. We'll do the advisement process and get you selected into your coursework. And chemical engineering, you should know, is that these specializations and emphases has nothing to do with your first set of courses. This is something that you go through and learn more about in somewhat of an experiential process, right? You go through the courses, you see what sounds interesting to you, what you're navigating, or excuse me, what you're gravitating towards, and then you can learn a little bit more about that. But Karen, you want to introduce yourself as the undergraduate advisor? Karen, I think you're here. Oh, there you go. Yes, but we don't have your camera on. We can't see you. We'd love to see you.
I'm here. Can you hear me? Hi.
There we go. Hi, Karen.
Now. Okay, hold on. Hi. Hi. I'm Karen Wu, the undergraduate advisor for chemical engineering program. We do mandatory advisement every semester, so I go through and create a course plan for you, and then we will discuss, if you come in with transfer credits or AP credits for GE classes, then we would remove the GE courses that you have satisfied, the categories you're satisfied, so we can move courses up. And then if there's room, then if you want to do a minor or take additional courses outside of the curriculum, then we can always add those in there. And then we always work as if the classes are conflicting, then we will see if we can find another class for you to take that would still keep you on track. So that's the process for choosing classes.
Yeah, I think what's important to know is that you have help. You're not alone. And what Karen talked about with mandatory advisement, we make you work with Karen. You have to go through advisement. You have to have a discussion. You have to be able to ask questions. And if not, we're going to ask questions of you. This is something where you don't do it by yourself and you're not alone. And I think what's also important, Deb asked this question about how many students. It changes each year based on interest level as the applicant pool, but roughly it's about 30 to 35 students are going to be coming in. That's our target for this upcoming year. And our incoming first year class is only going to be 410 first year students. So it's a little under 10% of the entire engineering school are chemical engineering students. It's a department that's focused and small with personal attention, and there's a lot of faculty that are there to help you with this process. It's complex, it needs support, and more specifically, I think the thing that everyone should understand about any engineering discipline is that it's hard. And so you don't get through this without help. You don't get through this without supporting faculty members, supportive staff, and academic advisors. That's why we're here doing this work. Can we talk a little bit about this idea of it being hard, guys? This is something that I think people skip over, but it's hard.
So it's interesting. People when they ask me what I do, right, and I tell them I teach at USC, and then they always ask, well, what do you teach? And I say chemical engineering, and they go, ooh, that's hard. And I'm like, it might be hard, but if you really like it, it's not that hard. Now, that's not not to say you don't work a lot. I work a lot as an instructor, and I've always worked at being an engineer. You are going to spend a lot of time working on your degree, but at least for me personally, I don't think of it as hard because I like it.
Absolutely. There's a positive feedback loop, like it could be hard, but you're liking what you're getting out at the end. And I think that's what happens with a lot of engineering students as they go through this program.
Yeah, I think a lot of the challenge for students entering the degree program is managing your time and staying ahead of the workload. In some like liberal arts disciplines, it's possible to cram for exams the night before. That's not a good approach for engineering. So learn to manage your time well and to start assignments early. Seek help if you are having difficulty. Don't wait to the last minute.
That's great. Well, with that note, I'm just going to wrap this up here. And for all of our students that have been admitted to the chemical engineering department, again, congratulations. We're excited to get you started. You should know that, this is why I love working at USC, because we can get faculty together at a real quick notice to talk to students because they want to talk with students. And hopefully you've noticed that they want to talk with you, they want to meet with you. And all of us, I think I could speak on behalf of all of them, including Karen and the rest of our staff at the university, we can't wait to see you on campus. And we hope this whole thing gets over really quickly so we can talk to each other face to face and be back in those labs and be back in those classrooms and engaging and this is a hard time for everybody, but we're working as hard as we can remotely to make sure that everything's going to work out fine when we get back in place. So if you missed any part of this, we're going to be putting the video up on our YouTube channel, and we'll also be taking the audio up and making it a podcast episode. More information about the degree programs and everything else is all in the stuff that we sent you, including viterbiadmission.usc.edu, specifically chemical engineering is viterbiadmission.usc.edu/CHE. So if you got any other questions there, check it out. If you have any questions for us in admission, let us know. Our phone number that we're answering remotely is 213-600-9919. Again, that's 213-600-9919. It's ringing on our cell phones here at home, so we're happy to answer those calls. And make sure that you get your commitment deposit in by May 1st. That's the National Candidates Reply Deadline. You can do that at your admission portal, admission.usc.edu/status. Thank you again so much. And to our faculty, Dr. Ershaghi, Dr. Young, Dr. Nutt, and Karen as our undergraduate advisor, thanks for joining us. We really appreciate it. And for all of you out there, fight on.